One thing about the previous video is that for the infinitesimal element, this, we take the h here to be equal to the distance from this to the top. This is the infinitesimal element. I draw it big. Okay. We took the h. This is the top. Okay. We take h to be equal to this. But what about this? This is one point of the element, infinitesimal element or surface. What about this h? Okay. Or for the extreme case, let's take this point and and substitute its distance, which variation from this is the maximum. And let's see what happens. So what is the distance of this point? This is dh. Okay, so the distance of this point from the top would be h plus dh. This is h, this is dh. Okay. Now let's substitute, instead of this h, let's substitute this. So that would be 0, and a1 was 2 times 1, 2, okay, rho g h plus dh dA, okay, which is this rho g h plus rho g dh which is 0 to 2 rho g h parentheses plus rho g dh dA. Okay, now let's write it here again, which is let's multiply by dA, rho g h dA plus rho g dh dA. Now here, this is what we call an infinitesimal of the second order, because it got two infinitesimals multiplied into each other, and with respect to this one is very small, and we ignore it, or we take that to be equal to 0. So this is around rho g a, the integral rho g h dA as before. So that doesn't make any difference if you took any of the points of the infinitesimal elements or the surface. Okay, you know, and we got the same thing for calculating the areas under the curves. So this is our curve, this is A, this is B, and this is our infinitesimal surface. Let me draw it here bigger. Okay, this curve is y equals to f of x. You know, the length of this is y, this is y, this is dx. So this, and you know, draw this parallel to the x-axis or dx. This is also y from here to here. And what is this? This is the infinitesimal change of y due to dx. So this is dy. And now the area under this curve above x-axis between A and B, these two vertical lines, equals to the sum of all of such an infinitesimal surface. Okay, so let me so would be the integral from A to B of this. And what is this? The area of this is the area of this rectangle plus the area of this little triangle, which is y dx plus dx dy over 2. And again here, this is an infinitesimal of the second order and ignorable with respect to this one. So this is our old integral y dx from A to B. And you know, again, here if you take any y instead of this y, take for instance the y of this point, you know, you would end up with this. Because you know, this, what we did was for the y of this point, which is, you know, got the maximum variation or difference with respect to this one. So if you took any y in between, you would end up with this. Okay.